Hello, everyone, and welcome to our Operational and Real-Time Modeling webinar. I'm Lauren Scheibe. Before I introduce our speakers, I would like to welcome and encourage you to, engage with the presenters in the Q&A box located on the right corner of the GoToWebinar interface. We will try to answer as many questions as possible during the last 15 minutes of this webinar. Please note that all phone lines will be muted. After the webinar, we will send an email to watch the webinar on demand. Today, we'll be discussing operational and real-time modeling with two utilities who are at the forefront of innovation. Our first speaker today is Kedrick, Denver Water's lead hydraulic modeler. He specializes in hydraulic and water quality modeling of distribution systems, collection systems, raw water systems, and transients. He has worked extensively on GIS integrated hydraulic models and the benefits of AMI for distribution system modeling. He has been focused on SCADA integrated, optimizational, and real-time modeling for the past decade. Our second speaker today is Ron Smith, System Optimization Analyst at Colorado Springs Utility. He is involved in the integration of real-time optimization modeling into the distribution systems. Other projects involved automation and optimization of the distribution system. And lastly, I'd like to introduce Greg Brazo, Regional Sales Manager at Innovize. He will be conducting our Q&A at the end. Kedrick, I'll hand it off to you now.
Good morning or good afternoon, everyone. Just wanted to start off. We're going to have 5 different polling questions, so I'll be reading 3 of these, and then we'll have 2 at the end. But the first one is just wondering if your organization has ever considered operational or real-time modeling. And while you guys answer that, I'm just going to kind of get into my presentation here. So I'm going to be talking about what we're doing at Denver Water right now with operational/real-time modeling. Just an overview of my presentation. I'm going to just give a few terms, talk about what this is, talk about how we made the case internally to do this sort of thing, just some experience with setting this up that we had, and then how we're using it now and how we want to use it in the future. So from my experience, people talk about real-time models, and they kind of just mean it's SCADA integrated. So there's some sort of connection between the historical database and the hydraulic model. Typically, you're going to update some sort of boundary conditions. Common ones would be, if your pumps are on or off, where your tank levels are, how your valves are operating, and then you're going to compare results and, common ones again, flow level, pressure. So that's kind of what we're talking about. It's kind of a step away from traditional modeling where, a lot of people, max day models have been common for people to calibrate and use those for planning and fire flow and, some worst case outage scenarios. Some people have done some maybe lower demand periods where they have water quality issues, but, traditionally people haven't really tried to have their model mimic every day of the year. And that's kind of what we're trying to do with operational modeling. So we want to do detailed system analysis that can mimic daily operations and really match any scenario. Do we have a pump station out right now for some emergency repairs? Do we have a conduit out for some other reason? What's the demand today? Not just, one time, but, is it 200 MGD, 240? So trying to, really get into details on every single situation you can encounter in a distribution system. Just a little history. This started off before I got to Denver Water, but they started watching the market around 2011, 2012, just kind of see what people were doing as the technology was first being released. In 2014, there was a water quality study done, or started, but the main idea with that is we wanted to do a tracer study to figure out how the water was getting out near the airport and how long it was taking from some of our plants. So that was the main idea, but part of that, we looked at different real-time modeling softwares, and it was pretty interesting at the time. There was 16 in this report that was delivered, and some of them were one user in Singapore doing this. Some of them might have been 2 people in Europe somewhere. There wasn't really a lot of people doing much of this at the time. There's also another study we did with Excel in 2015. That's the local power provider here. I was looking more at a different angle from modeling and more from energy saving standpoint, but it was tied into making some real-time decisions. So, Denver Water had some experience with this, and last year we decided to try to make the business case for this. We happen to have a new Business Technology Management Office. I'll refer to that as BITMO, but they control any new IT purchase. It's a pretty detailed process. And then not only do you have to convince upper management that, hey, this is actually a good idea, but then when you're done, you get ranked against anybody else's case, and it kind of determines when you get implemented. It's a big list of the main benefits we had proposed. Mainly, we wanted to just refine some of the areas in the model that, were typically tricky when we're trying to do a calibration. Also take the model to an operational level, which will enhance some outage planning, give a tool for operators. And then a lot of this had some direct benefits for water quality that I'll get into in a little bit. So to make the business case, we also had to list out the costs. The software obviously costs something. A new server, probably wish I would have got 2 for this, but we can cross that at a later day. One's fine for now. And then just the IT time to set this up and install the software and configure some groups. I actually got control of one group for accessing the server, which gave me a little taste of power that the IT people must feel all the time. So it was a new experience for me. And then my time linking the model to the historical SCADA database and then refining the model, which that's just kind of a part-time thing that I do as part of my role here. This business case is kind of interesting. There's 20 tabs in the spreadsheet. It got condensed down into one. So this is just a little summary that upper management saw. Luckily, we had all green lights here. Basically listed out some major objectives, how it aligned with the strategic plan of the organization, and then just a little scope and schedule on that. And so there were 7 cases that got approved last year, and this one came in number 1, so we got to start this in early January. So the first thing you get into is integrating this with SCADA. So the people who maintain our historical SCADA database, they gave me a specific username for the software to use, and then they also made a view that had the data in exactly the format I wanted. So that was pretty nice to be able to access the data. And then after that, it's a lot of time understanding the feeds and raw data formats. A lot of times if you extract data, the program you use might extract it in a friendlier format than the raw database stores. Sometimes you just kind of need to know what sort of information it's storing, what are the units and stuff. So based upon that, you can decide how you want to translate the data and link it to a model, which I'll be talking about in detail. But one of the things is there's not really a set answer for some of the trickier things that you're going to try to integrate. So for me, I have quite a few feeds. I have approximately 1,300 feeds that I'm looking at linking between the model and the SCADA, some of them to update boundary conditions, some just to compare results. So for me, I had to make some pretty insane Excel files. This is looking at my, kind of on the top, I have my pump table, I have reservoirs on the lower left, and then valves on the right. And I use this just to track all sorts of things. Kind of these blue cells are just general information for me. The middle cells are all the SCADA tags, and then I have some notes on the right-hand side and whether I've integrated it or not. We do include in our model all 68 distributors that we deliver water to, so we don't have SCADA on some of their things, even though there are benefits of having it in the model as opposed to just a demand. It gives us a better idea of what they're actually doing in the system. But for this, I can, look back in the future at any pump and be like, well, hey, these are the SCADA tags associated with it. So this is nice because I won't, after I can get the configuration done, which is about 98% complete, I probably won't touch this for a while. And so when I need to come back to one of these because the tag changed or something, it'll be pretty beneficial just to have all this mapped out. This also helped me know if I needed to translate data. So a couple things that are interesting at Denver Water is we don't store binary data. So we don't store like if a pump is on or off, for example. And then another thing is just the way valves work. So an EPA net, a valve status is not something that you're going to find in a SCADA system. So how do you get valve status from what you have in SCADA? So I have a few different examples here. If you look at this table, feed names are kind of my feed names. I just define the connection name myself, but then I have these lookup tables, units, and then some offsets and factors. So like kind of in here is where I can translate a lot of data. So a few good examples of this to be aware of. One is I have one valve, but I have 2 feeds. One is position, one is status. These actually look at the same SCADA tag, except the status one is using this lookup table. So I have these different lookup tables that I use to translate data. And so if you look down here and just find the same one, what this basically entails is if you're looking at this, if I come in and my SCADA returns a value between -5 and 5, I'm going to assume that valve is shut, and 0 is what EPA wants for a shut valve. I do this for two reasons. One, if I put the lower limit at 0, I've seen SCADA systems sometimes come back and be like -0.1% open. Well, I know that valve's shut. I wouldn't want it to use a default value. The other reason is because if the valve is like 0.8% open, due to the head loss curve that I have for some of my control valves, I would be letting flow through there, and I know it's shut in reality, it's seated. So again, just trying to get around that. And so in this case, I'm defining if the valve is closed to 0 or if it's operating, if it's active. So these would be for a control valve that our operators actually throttle. Now, what about some other type of valve? We have valves that the controllers just open or close. They're just basically to block off flow from one direction to another. So in this case, it's basically the same thing, only I have a 1 because if it's open, I just want to have it open. These are valves that are never throttled, and so I don't want to do that. Similarly, I didn't put this as an example, but if you look at the top row, you'll see VP to pump status. Again, we don't store pump status in our historical database, but for our fixed speed pumps, they all have a downstream valve that is in SCADA, so I know from the position of that valve if the pump is on or off. Similarly, at a VFD station, might not have status again, but we do have flow. So knowing based on the flow, this is MGD, but if I have a very low flow value, I'm going to say the pump is closed, and if I have a higher value, I'm going to say it's open. So one other thing that you get into with this is setting up operational controls. So you might have places where it's not normal operations, but you know, something that is used from time to time. And one of my best examples is one of our major facilities. It's a pump station and a control valve, move water 2 directions, and it balances flow between 2 plants. Now, if a plant's offline, it's pretty normal for this station to be used constantly, but other than that, it's not. So it's kind of an interesting facility because it's not normal operations unless there's an outage, but it's not abnormal because it's connected to a big conduit. They want to keep it fresh, and so, you know, pretty much daily it's at least, you know, opened up a little bit to make sure the water's not sitting there. And so in a case like this, there's really not a way to put in a control of when the operator would turn it on based on water quality, because it's just not a consistent little thing. It's something they kind of track themselves. So what you do is you can put in closed only controls. So this way, if I'm running the model and the station is on, what I have is a control to shut it off so that I don't overflow the tank downstream. I don't need any trigger to turn this on. You know, maybe in the future, if I set up models specifically for plant outages, I may get into looking at that, but there are a lot of times where you might just put in a closed control, and it's maybe the operator's doing something to, you know, maybe it's a pump station they don't use a lot, but they like to run the pumps to keep them fresh, things like that. Just looking at integration order, if you guys ever look into this, it's always nice to set up your tags in order, and I've learned this from multiple systems I've set up over the years. Tank levels are pretty straightforward. Boundary condition, you can update the level, it's easy to compare. I always recommend allowing overflow. If you're in InfoWorks WS or InfoWater, you can do this. And it's nice because what happens in reality, if the tank gets full, it normally overflows. And if you're just normal EPA net without this option, it's going to artificially pressurize the system. You're going to start sending flow in directions it wouldn't really go, and it's just a lot harder to troubleshoot. Treatment plant production is pretty straightforward. Obviously, if you get your supply right, you're set up pretty good. And then pump stations, you know, typically is the pump open or closed? You can compare flows and pressures. I encourage people not to try to mimic the pump cycling. You want to mimic the pump operation. So if you can mimic, you know, maybe they have a low duty and a high duty pump and you know when they tend to use them, you can do that. But if they have like 3 of the same pumps and they cycle through them, it's typically not a whole lot of benefit to worrying about mimicking the cycling as long as the station is operating as you would expect it to be. And then VFDs, I don't really have time to go into this, but you know, you do have to be careful and play around with these quite a bit more in my experience. And then when you get to valves, basically filling valves are pretty simple. A lot of times it's just open or closed, or maybe they open it to a, you know, 50% is pretty much their standard position for opening. So those tend to be the easiest type of valves. Major control valves are a little easier as well because you can either say open or close, or you can get that position if you have a good head loss curve. If you do have a SCADA system where the operators can enter flow and the PLC will set that, then you can also do those as well. And then comparing flows and pressures is the main idea. The trickiest ones tend to be with PRVs. I always encourage to compare pressure and status to see if the PRV is active. But I say don't leak these in too fast. You can chase your tail for quite a long time, and I've done this on quite a few networks. So right now, I don't have any PRV linked in to actually determine if it's open or closed or to set the downstream pressure in my model. This is purely a comparison thing to see how much I can tweak my model before I decide if I need a PRV linked in. That'll save you so much time if you're ever doing this. So just quick polling question here would be, what is the biggest hurdle to committing to an operational or real-time model? Just looking at some feedback from you guys on that.
Kat, I can talk to that just a little bit here. This is Greg Brazzo, and I've been in industry for quite some time, both on the consulting side of things as well as the software side of things. And over the years, the main answer that I've gotten to this question has a lot to do with staffing. It's not necessarily just genuine buy-in of predictive modeling, of operational modeling, but historically I've gotten a lot of concern over taking folks on the planning side of things, folks on the operations side of things, and how it's going to work, where you're going to put those folks together in a room to hash out the best way to move forward with these things. It's just something to stew over for a little bit, but I've heard that a lot over the years from a lot of municipalities. What I'm generally hearing these days is that the planning group and the operations group in a lot of districts, municipalities, tend to be getting closer. There seems to be a lot more communication. I don't know the exact reason behind that, but I think it's good for the industry. Just something to think about.
Thank you, Greg. Just to kind of tie up some things. I mean, we don't. This is like right on the cusp of being able to, I guess, starting for this. Like we're just on the cusp of going from kind of test mode to getting some data out to people. But we've been verifying the model under different operating conditions. I started doing this a few months ago. It was the first runs that we did, and that was in winter demands. Colorado had a very, very cool spring, and so all of a sudden today's our first 90-degree day, and so I'm looking at completely different operations than I was even 3 weeks ago. Just refining some of the control valve and pump behavior. I have a few conduits that have always driven me crazy, because it's like if I'm on a winter day, my head loss is spot on. If I'm on a max day, it's like off by 10 feet after 8 miles, and so I'm going to try to fix some stuff with that. Obviously, everyone's confidence in the model. I guess how you look at this, either never calibrate a model again, or that's traditionally maybe you could look at this as you're never going to stop calibrating the model, because you're always trying to tweak this and that to make it better. Give some pressure and flow estimates in the absence of SCADA. So it's pretty cool. People have asked me for this before, and now if they do this, I can just run a steady state model with all my tags linked in, and it'll give me the best estimate of flow and pressure at the current time. We do have some people using EPANet because InfoWater is too hard to use for them. So that's going to be nice. And then starting some demand forecasting. I, again, don't have time to get into that. Something that I hope to start this next week, actually, but we're going to try to be able to give people a current real-time water quality in the system. And, near real-time, with the SCADA latency and the time it takes to run this, it'll probably be like 20 or 30 minutes out of date, to be honest. But the idea will be to have a web browser where people can go in, and it's like someone at the lab and they have a weird sample and they want to see, like, well, hey, what do we think the water age was when we took this sample? They should be able to figure stuff like that out, which should be pretty neat. And then we're also getting into some advanced water quality forensic runs. So operating the model how it was based on SCADA for 2 to 3 weeks. And then pH is one that we're starting up right now to look at. Nitrification is kind of tagged for next year, and we might look at even system operations when we're taking facilities offline. Can we change some of these operations to enhance our water quality to some of the targets that we're looking at? I would always say right size your models for a purpose, which depending on your model may not be a big deal, but our all pipes model is about 360,000 pipes. So I'll run this one for daily outages, outages and daily calibration stuff. When we run water quality, never need water quality at a dead end with no demand. It just makes the results look bad. So we'll use facility management to remove all the hydrant laterals and stubs and bypasses. That should knock us down about 90,000 pipes. And then for operations, if load control looks at this in the future, what we want to do is get that down to about 120,000 pipes so it runs faster. Having said that, they still have to, same number of SCADA feeds. So the query on the SCADA system is, you can't really improve that. And then just quickly, some possible uses to wrap up, just stuff that we're going to show O&M that they may use it for. They could monitor pressure and flow on their own, not having to call me up. In the past, we've given them a monthly outage model just for them to be able to mess around with. They can now do this based on current conditions, and they don't even have to, bug us or try to use EPA net, which should be nice for them. New operators might like this for training. If they want, they could standardize operations. It's kind of up to them. That's not obviously my department. People might want to run this, get in and say, hey, well, if I run the system like this for the next 10 hours, maybe I don't pump during this time of day and, save some money and stuff like that. I kind of talked about the water quality. One of the GIS integration things that'll be interesting for me is every time we replace a PRB or control valve, it gets a new GIS ID, which I know how to sync that with the model, but I don't even know if that means a changing SCADA tag. So it's just some process that I'm going to have to look at in a few months the next time I update the model from GIS, and then possibly tie into optimization or a bigger decision support system. And that's kind of it for my presentation. I'll leave you with one more polling question, and then I'm going to switch it over to the other presenter. But next question would be, do you think that your operators would believe in an operational and real-time model? It's just been one of the more fascinating experiences of my life, getting to work with engineers and operators both. And so to me, this is a really fascinating question. And as you answer that, I will just turn it over to Ron Smith, Systems Optimization Analyst down at Colorado Springs. He's a great guy. He's doing some really cool stuff he's going to show you about. So I'll let you take it away, Ron.
Yeah, and Ron, before you get going, so this kind of tees into the points that I was trying to make a little bit earlier. In a lot of cases, historically, we've gotten some buy-in challenges on the operations side of things. Tends to be on the operations side of things, but then what we've seen kind of over the years is folks on the operations side of things have actually been using modeling software and software that can aid them day in and day out. And so I think we're going in a really positive direction when it comes to this. But just curious what the pulse of the industry is now, because we've got folks really from all over the country at the moment, and I've seen this going in a really positive direction. So with that, Ron.
All right. Good afternoon, folks, or good morning as it may fit. And I'm going to take it from here. I assume everybody can see the screen. So as Ked said, we implemented or took on the challenge of real-time modeling in late 2014. We purchased the software to implement it. One thing, the second item on this slide that I really want to emphasize is they created a standalone position from water operations to integrate with the engineering folks, our water planning and design group. I actually filled that position, and it really started from the beginning that the company was behind this, and they support this integration. One of the things that's not listed on the slide that I really want to point out as well is our SCADA historian PI data team is also responsible for the updates or the maintenance of the software. So, I want to give a shout out to them as well, or our company for putting them or integrating them into that portion of it. So go Pi team go. You know, we began by creating the operational model and began efforts to integrate it into the daily operation of our distribution system. In the middle of about 2015, we rolled it out into the control room and began the training with the modeling portion of it with the operators in the control room. Currently, it is used for daily decision making and system operations for our entire water system. And I can tell you, you know, maybe not as large as Denver Water, but we have a lot of moving parts in our system. You know, one of the most important things that we focused in on early on is just, and I think Kedrick touched on it as well, is just having an accurate demand in the model. You know, our winter months might be 40 million and our summer months can be 120. And then we have the shoulder season in between. One of the features in our software is an ability to scale the demand, both globally or by pressure zone. So we have a ratio in there. And in this case, you'll see the 0.484. And where we arrive at that, we use an Excel spreadsheet to determine our consumption based on production rates and tank levels. So in this example, for that day, an operator would have predicted a consumption of 65.5 million gallons in our system. So we've created another spreadsheet with the factoring to determine, you know, what it would scale the traditional demand to. And in our case, in the summer, it's 125.4. So this 4.84 would be entered into the demand scaling window. And then when they run the model, and the operators do actually run the model in the control room, you know, then they would be intending to run 65.5 million gallons. You know, moving to the next slide, and this is another window in the model. You know, at the end of the 24-hour run, it consumed 65.226 million gallons. So, you know, we're pretty accurate with the right demand, and then we will adjust that as the day goes, if it goes up or down based on a weather event or you know, a main break. If it's going to consume more water, we still marry the forecaster to our demand, and they'll go edit that, you know, as the day goes on, so that they're still running an accurate comparison. But we found that to be, in our mind, the most critical thing, is to have the correct demand leaving there. You know, our methodology by using this, you know, obviously the operational adjustments are being made using modeled results rather than operator intuition. You know, I myself operated before I took this position, and I would operate a single valve, and I may have thought I know what could happen to every tank, but this is taking it to the next level. You know, one of the big issues that we've had at this company is just the movement up and down of treatment plant rates to affect tank levels. And we make the treatment plant production rate decisions through the model as well. We have eliminated the majority, or, you know, a day where we might have made 5 changes in the past, we make 1 at this time. The majority of our flow control valves and pump stations in the model are operated using a live control feature, which I'm going to segue into next. But the live control is a major leap in the accuracy of the model, and I'm going to get into that. You know, then you get into the predictive state looking out past the current time of the model run. We look out 24 hours, and they will make manual entries being a predictive move that they want to happen to a valve or a treatment plant rate, looking forward to balance the system. So live control is in the menu of setting up a valve. And if you look here at the data origin, it says that it's live data. And by that, it means it pulls the SCADA data every 10 minutes, and then it logs it into the model as the flow that was happening at those intervals or pump statuses on and off. And what it creates by taking all of this data is, the graph for real time is really going to be the predictive result as well, until you do update the data or tell it to do something different, where in this case at 5:50 in the morning they closed the valve, so it went to no flow. If you look at the graph for that, you've got two lines here. You've got the predictive line, or the blue line, and you have the green line, which is our actual SCADA data coming in. And, at that point, the valve is operating and reflected in the model exactly as it's really operating. So this live control feature is it really makes things pretty finite and precise. So, at this point, we have probably 5 major flow control valves using this methodology. The next push would be to get the pump stations, because we run ours on level control, but with the live control theory, we should be able to just monitor on-off status. And then as a pump is turned on or off, you would just resimulate the model and it would refresh the data, bringing it into its current state. So this has been, another key element into us being able to operate our system using the live model. When we make a predictive change, like here is one of our major treatment plants, and it's tracking pretty close. I mean, there's a lot of moving parts downstream that can affect this level. And if you look, it spills at 24 feet, so it's starting to get full toward the middle of the day. An operator can go in, and here's your live data. And at 1 o'clock in the afternoon until the end of the run, we start at 4 a.m. So it would go to 4 a.m. plus a day. They changed the treatment plant production to 22.5 mil versus the 27 that it was running. After they make that change, this is the 24-hour result of that same tank, and you can see about 1,300, both in the model and with a little bit of a lag. That's actually where it started trimming the tank level off. It only got to a high of 20 feet, which is where they would have wanted it at that time of day. And then it ran out through the rest of the day. That's pretty accurate in my mind for a treatment plant tank that has a lot of downstream valves that can affect the level. This methodology would be used for all of those valves as well. So they literally would go into the model and make those moves ahead of actually making them in the SCADA system. And this is just an example of how that played out. And that's, again, the green line is real data. So that was a good day. Moving into some of the benefits, and there's obviously more than I have listed here, but it does standardize operations. We have 5 operators, and this is making things a little more predictable. Our distribution crew at one point would know who's operating by the way, the differences of how it was operated, but we're starting to confuse them a little bit and gain traction with balancing it and standardizing it. I can also speak to the second one. Operators gain a much greater and broader knowledge of impacts to our system by predicting the changes through the model. You can see all of the fishbone and cause and effect. Our system operation during planned and unplanned outages using the model we've greatly benefited from that. You can plug in main breaks, several different things can be populated in there. There's obviously better operation during significant changes in our system demand. When I mention a weather event, we can be moving along at 120 million gallons in the summer, and if it rains in the afternoon, drop to 80 million gallons. And by adjusting that global demand number, you can bring down, and obviously if you just simply change that factor, your tanks are going to fill up, and then you can both figure out what changes you might need to make it to treatment plant rates, or if you can push the water out into your tanks. But they now make those changes in the model using the same valves that they would operate in the system, and then they just push those changes into our operating system. We've achieved a far greater accuracy in our operation of the storage tank levels as well as overall system storage. Some of the future enhancements that we'd like to make, and some of these, this is one of the first or few times that our folks, the developers and the technical team at Innovyze have seen is, that global number that we edit, and I have side by side is the live control. It's a big ask, but it would be very nice if you had a clock type scenario in there where you can say for the first 12 hours, I want to function at 120 million gallons, and then I've got rain coming in and I want to function at 80. So, perhaps in the future, if we could break it down into a time-based thing and have different consumption or demand rates at different times of the day, that would be phenomenal. One of the other enhancements, and it's the same page, and we've started doing it at a kind of in its infancy, is taking an individual zone, based on a visual that the tank is going down faster, even in real life, than the predicted result, and you don't have any main breaks or any pipe breaks in that area, is to, raise the demand in an individual zone and change just one of those factors above the global, and then figure out, how much more water is being pushed through that area. So again, we've just started using that, but had some pretty good success with that. Obviously, this is the furthest out, but it would be my goal is to take and create an interface between the model and our SCADA operating system, to where, perhaps we set a script every day that, this valve needs to move at this time and this pump needs to come on at this time, and then, maybe there's a pop-up like when you accept a Wi-Fi signal and hit accept, and then it pushes those changes all the way into SCADA and makes the moves in the system for the operator. And that's quite a ways out there, but it is our end goal here, is to have an interface between the model and SCADA to where it pushes those changes all the way through into the operating system. Again, it's quite a ways out there, but it can happen. And I would say my other pitch and my shout out would be for Innovise, and anything that we've asked for, given time, has been supported. So, I want to go back and touch on that again, both internally in our company and with Innovise. It's just the support is phenomenal, and I think that's made probably the biggest difference to get us to where we're at. So with that, I'm going to turn it over to another polling question, and then look forward to questions at the end. And thank you, folks.
All right, and just for the time being, let's folks take a look at this, and we're going to give you about a minute to look through this and actually provide answers here. So. Okay, that should be enough time. And then we're going to move on to one more polling question. Then we've got a lot of good questions that have popped up during the course of the webinar here, which we're going to address one by one. So this one is, how comfortable would you feel implementing an operational or real-time model? And again, I think this is trending in the right direction, generally speaking. Just from a level of acceptance, I think we're seeing folks that are becoming more comfortable with the idea of going down this route. Whereas, 7 or 8 years ago, I think there was some trepidation, and I think a lot of that just has to do with the level of communication between the folks on the modeling side of things and the folks on the operations side of things. So, give you a few more seconds to run through this. All right, so let's move on to the Q&A section here. Like I said, we got a few really good ones. I've kind of assigned those to our presenters here. We're going to start with Kedrick, who's going to give some answers to some of the nice questions that have been answered throughout the presentation here. So, Ked, why don't you take it away?
All right. Just a general comment. Rod and I weren't trying to really give plugs, but there are some questions in here related to this. So just to FYI for everyone, the software we're both using for this is called IW Live. But then to get into some of these questions, so the first one here was, what do you do when SCADA is not available for system flows? So it could be kind of a two-part question. One is, if telemetry is ever missing, you kind of get to put in a min and a max value. So even if it returns some crazy value outside the range, or if that sensor goes offline, if it's not there, it'll generate a warning letting you know that, and then you get to decide a default value you want to get to use in that sort of case. If you didn't have SCADA for system flows, that could be another thing. Honestly, we have over 100 control valves. These aren't PRVs, these are just flow control valves. They don't actually set the flow, but operators twist them open and shut. For the majority of these, over 90% of them, we don't have flows, and this is where you just kind of got to use your, tank levels and other things that you do know. So you kind of like figure out where you do know stuff and like kind of go around the system. And I find if you have areas on the periphery, if you can kind of set some of those, the more small areas, like you might pump up to one area that's kind of like, hey, if I just get the operations up for that zone, then it's kind of set. Maybe that'll help your unknown areas where you have less flow meters. So it's always setting what you can do as much as you can. There was another question here. What's the largest adjustment from going from a max day model build versus building for operational models? I would say the biggest thing, and this is just from my experience, like you can't cheat. And I say that because it blows my mind how much I used to cheat, even though I might not have thought I was. So, you can do some things to mimic the system for one day, and then you try to go and apply those assumptions to another day, and you're going to be pretty far off. And so it's a process, and you're not going to like build an operational model in one day. You're going to work on this, and you're going to be feeling really good about yourself for little while, and then the demand condition changes, and you go from a summer month to a kind of medium size demand, and all of a sudden it's like, oh, I'm not even close, and you can get discouraged. But it's something you just got to keep going after. So that's the main difference for me. You're never done after one day. You always got to think about things in different ways than you ever have before, because what might work for one day doesn't best represent the system on all days. There's another question here about what would allowing overflow entail on a tank. That was actually, it's a modified InfoWater feature that was put in, and I'll stick to that one because I think most people in the US are using that, if anything, from Innovize. But if you look at a tank in the browser where you have all your attributes, now at the bottom it's just a tick box, and by default you're going to be on no, but it says allow overflow, and you can set that to yes. And when you set it to yes, it basically will just start spilling water at that max level that you have set for that tank. And in the output results, you can actually track the instantaneous overflow rate, or you can calculate the total overflow volume. So those output fields are added if you tag a tank to yes. So it's pretty simple to do. Another question here. Denver Water, am I the only modeler? Do I share responsibilities? If the latter, how do I distribute efforts or share roles, especially with regards to updating the model? So I maintain our distribution model. We have another gentleman who maintains the reuse model and also uses the InfoWater model. We have two other people who use InfoWater, and then we have a handful in my group who use EPANet, because for what they do for plan reviews, it just is easier and faster for them. And then some people in our operators, some of our operators have actually used EPANet in the past. But I guess to get to that, for updating the model from GIS, that's something that I personally just manage right now. It's something that I'm trying to write a process manual so that anybody else could do that. But essentially right now the process is I kind of update and maintain the base model. That model feeds into what we're doing with real-time modeling. Other people take a version of that model and work with that if they need something updated. That's kind of can trigger an update, or we tend to try to update it about every 6 months. And then I guess one last one for me, and then we'll give a few to Ron here. In the West, water rights impacts how water is used. How does water resource availability impact how your system uses real-time modeling? Right now, that's an excellent question, because, I guess the dream goal, it's kind of pie in the sky still, would be to have some model that tied in water rights to how we're balancing water in our raw water system, which is ginormous. I mean, thousands of square miles. And so, right now we haven't really done that. Our water resources group kind of look at what's going on with our water supply, with our what's going to come and what's the projected use, and they kind of work with load control to figure out what load control is going to set each plant at each day. So when I do the real-time model, I'm linked into what the plants are doing every day. So that's how I know what's doing. We don't currently have a link between the water resource and the real-time model. It's more of, traditional process to get to knowing what the treatment plants are, which is all I need. But I will say that is maybe a long-term goal, is to integrate this into some bigger decision support system. So Ron, do you want to answer a few of these?
Yeah, I've got 3 of them up here. So the first question is, what would you suggest for a system that is manually controlled by operator intervention in response to system conditions? And I guess I had to think about that, but while we have a lot of valves and pump stations that are automated off a level control or flow control, you know, it is that operator intervention that would dictate that it needs to change flow. So I actually think this is a good fit for the real-time modeling, because you have either the live control feature that you could turn a pump on, or you can manually enter it, which is the same. I mean, they typically would still manually intervene into the SCADA system to enact the changes that they see from the model. So I actually think, if I'm answering it correctly, that would be a perfect fit for a manually controlled system, because you could make those decisions external to actually pushing them over into the SCADA system, and then the operator, similar to what we do now, would just make those moves over in the actual system. But hopefully I answered that correctly, but I think that I would actually use this product to make your decisions as a decision tool, and then just have the operator execute those moves. Another question, do your operators use InfoWater ArcMap to access the model? The IW Live model actually sits on ArcMap or ArcGIS, and it's converted to the IW Live. It's an XINP file, and it actually is converted over using the suite portion of the InfoWater. So it's actually the InfoWater model converted into the IW Live engine, where you can attach the SCADA data. So hopefully that answered that question correctly, but they technically are accessing InfoWater. It's just under the IW Live umbrella after it's converted to a file language that allows it to operate in there. You know, that leads into the third question for Ron. Do the operators run a hydraulic model, example EPA net InfoWater? You know, we found that there's a pretty steep learning curve for somebody who hasn't run a model before. And I think I touched on that in the beginning. I mean, that has been one of the transitional things, is to expose them. But again, they're running the InfoWater model through the IW Live software, which, you know, any changes to the model, you can't add a pipe or actually edit pipe or add valves in IW Live. So that's done in InfoWater, you know, and that's part of the maintenance package that I do. So, you know, they technically run the model in InfoWater, but they can't edit. So, you know, there's still the same learning curve. Actually, it was a little steeper because you have the SCADA data in there that gives you, you know, real time versus the predictive line. And if the predictive line and the real time line don't match, then you have that process as an operator to go in and determine what needs to flow, what pumps might need to be on or off, or even the treatment plant rate. And that's where we would go in and adjust it. So I know I kind of went off the tracks, but they do technically run the InfoWater model, and they're definitely running a model. It's just in the IW Live platform. So hopefully those answered your questions. For the ones that I was looking at, I don't see myself on here for any others. Nope. I think Greg may jump in.
You're good. Yeah, let me jump in here. So we're actually running out of time here, and so I don't want to keep everybody too long, but I wanted to thank everybody for coming in. From here, I just want to hand it off to Lauren to wrap this up. But from my own perspective, thanks Colorado Springs Utilities and thanks to Denver Water. Lauren, why don't you go ahead?
Yeah, if we didn't get a chance to answer all of your questions on here, we will definitely be following up with each of you to get you answers to your questions. Thank you also to Kedrick and Ron and Greg for taking the time today. We really appreciate it. If you guys have any further questions, you can see all of their contact information is up here. Hope you have a great day. Thanks.